Alright, so I think this is recording. We're taking a look at skill packet 5, exponential functions and logarithmic functions, and in this 5G we're solving exponential and log equations. So in problem number 13 I have this exponential expression with the variables as the exponents. I really don't have properties of equality to get this x by itself. So I do have properties of logarithms that are going to help. But since I'm eventually going to go to a calculator and use a decimal approximation for my answer to figure out what x, if there should be a solution for this one. I'm going to either take the natural log of each side or the common log, and students have told me in the past that they have a preference for some reason for the common log. So since it doesn't matter, I can use the common log, or I could have used natural log. Alright, so I do that to both sides of the equation, and now by the power rule these exponents come out in front, and now I have multiplication. So I do have properties that deal with multiplication, properties of equality, that I can now solve this for x. On the left hand side I have a single term, it has an x. I'm going to leave that alone for just a minute. And on the right hand side I'm going to distribute this number. It may not be your favorite number, but log of 6 is a number. I mean, you could get a decimal approximation for it, but I'm going to work with exact values. So this guy is 0.7781512504. That's just an approximation. Log of 6 is exact. But both of these terms in this binomial get multiplied by this log of 6. So I want to get my variables on the same side of the equation and the constants on the other side. On the left hand side I have a variable, on the right hand side I have a variable and a constant, so I'm going to subtract this first term from both sides of the equation. So on the left I get the term that I had originally minus this other term, and of course when I subtract it from the right hand side it cancels, it goes away, and I have just this constant. So now both of these terms have the variable of interest, so I'm going to factor out that common variable. I see my x right here and I see an x there, so this binomial still remains a binomial, but in the first factor I just have log of 12. I have factored out, I have pulled that factor of x out in front by the distributive property. And here I do the same with the second. So I know I could check it, that multiplication distributes over addition or subtraction, that you would take x times the first term, you would take x times the second term. So I haven't made any silly mistakes in factoring that x out. I haven't done anything with this constant, so it's just going to remain the same. Well, now on the left hand side I've almost got x by itself. That's what I really want, is to get this x by itself. Well, right now it's being multiplied by this number that's in parentheses, and so I'm going to divide both sides of this equality by that number that's in the parentheses here. Because this divided by this is just 1 and I have x. Now on the right hand side I have to also divide by the same amount to balance the equation. And I have to be able to read my writing to get my answer. So in the numerator, 5 times the log of 6. In the denominator I have this binomial, this two terms, log of 12 minus 2 log of 6. So there's my exact answer. I can go to a scientific calculator and get a decimal approximation for this. In the numerator I have 5 times the log of 6, and in the denominator I need to have parentheses around this. I have log of 12 minus 2 times the log of 6. Close that with the 6, then close it with the denominator, and I have this negative value. To 3 decimal places I have negative 8.0 0.155. Let's check that and see if go back to the original equation, and let's take 12 raised to this answer. Now, since this is an approximation, the left-hand side and right-hand side of this equation will most likely not be exactly equal to each other, but they should be pretty close. On the right-hand side, if I have 6 raised to the 2 times negative 8.155 plus 5, and you can see that it has 0.58, and then it starts to differ, 225 and 164, but the exponents are the same, so the same number of zeros, which 9 zeros, this is a pretty small number. So our approximation is pretty good. These are almost approximately equal. They would be equal to 3 decimals, I'll bet you. So let's bring up this guy, 0.582. Now where did the other guy go? Yeah, here. Oops. Well, will it let me delete? I'm wasting too much time trying to show you that. I had a base of 6. Okay, well, yeah. Look, I have 56 there. I don't know what I'm doing here. Well, it jumped on me. Let's delete that 5. There we go, 1.582. Okay, to 3 decimals they are the same. So this is a pretty good approximation to this exact answer. Alright, so let's take a look at this next one. Now it's a log equation. On the left-hand side I have 2 terms. The term of interest is this one that has the variable. So let's subtract 2 from each side to get this term by itself. If I subtract 2, I have a negative 12. So on the left-hand side, I have 2 factors. The second factor has my variable. I need to get rid of this negative 4 by dividing both sides by negative 4. And I have the log base 3 of this expression, x plus 2. And negative divided by negative is positive. 12 divided by 4 is 3. And I've gone as far as I can go with just trying to get the term by itself. I need to use either properties of logarithms or just the definition of a logarithm. I'm going to convert this from log form to exponential form. So the base is 3. A logarithm equals an exponent, so the exponent is also 3. So 3 to the 3rd power is 27, and 25 plus 2, so this is 25. Oh, hey, class is about to start. Alright, so hey, I hope this helps, and I will talk to you later.